Hi Year 10s, welcome back. We are doing a new topic today and it is called Parabolas, Exercise 7A. I'll give you a chance to copy down the notes and then I'm going to fill stuff in. So you do that, pause it when you need to. Nice big diagrams, by the way. Alright, good job. Okay, so a couple of topics ago we did quadratic equations, if you remember that. We did factorising. So all that stuff's really important for this topic because when you factorise and find the values of x, you're actually finding you're finding intersections. So x-intercepts of a parabola. So I'll get to that in a few minutes anyway. But here's some basic theory. A parabola is a graph of a quadratic equation. So those equations you've used, like y equals x squared plus 3x plus 5, that's a quadratic equation. And it's a parabola. The basic parabola has the rule y equals x squared. So you know if it's got an x squared in it, it's a parabola. And a parabola is not a straight line. So a parabola has all curves like that. So there is not one part of this that's a straight line. A few little features you need to know about. So that's the basic parabola, y equals x squared. That's called a vertex or a turning point. So the point there, can you see it's really steep and then it flattens out, and then here it's the only spot where it's actually horizontal, and then it gets steeper and steeper again, goes up like that. So that point where it turns around, it's called a vertex, which is like a corner, or a turning point. So I will refer to it mostly as a turning point. And that's 0, 0, the coordinates of that turning point for the basic parabola. And that's a minimum turning point. Can you see here, it goes down to a minimum value. So this shape here is a minimum. When we talk about parabolas the other way around, then it becomes a maximum. But anyway, these are symmetrical. Every parabola is symmetrical. And its axis of symmetry is x equals 0. That's an equation of a vertical line. So if we put a line through there, that's the axis of symmetry. And that equation of that line is x equals 0, because the x value is 0. So if it was there, it would be x equals 2, or whatever that value was. But the y-axis is actually the equation of x equals 0. So that's that line there. The x-intercept and the y-intercept. The y-intercept, it cuts 0, 0, and the x-intercept is also at 0, 0. So they're both intercepts are there. Okay, so that's the general gist of what a parabola looks like. Alright, so now the first thing we're going to do is we're going to sketch these graphs. So sketching does not mean drawing or plotting. A sketch is just a quick, give me an idea of what it looks like. And we're going to look at transformations of this parabola. So here is our generic one. I'm going to call that y equals x squared. So that's generally what it looks like. It's an upright parabola like that. Goes through 0, 0. I didn't draw it very accurately, but you get the gist of it. Now, a dilation. That means it's getting thinner or wider. So a dilation, so y equals 2x squared. So the graph of y equals 2x squared, I'm going to draw it here, is a skinnier graph. So whenever you've got more than one graph on the same graph, you have to label them all. So y equals 2x squared. So if that's y equals x squared, the black one, this blue one, y equals 2x squared, is skinnier. So we don't know exactly what it looks like, but it's an idea, it's a sketch. So if I had y equals 3x squared, it'd be even skinnier still. Y equals 7x squared, it'd be very close to the y-axis. Alright, and the next one, so I'm going to write here, this one here is thinner. So that one there is thinner. Y equals a half x squared. A half x squared makes it wider. So I'm going to do this as a dotted line, because otherwise it's going to get too complicated. And that's roughly what it looks like. So this one is y equals a half x squared. So if you get this, anything greater, the number at the front, the coefficient of x squared, if it's greater than 1, see there, that's 1x squared. If it's greater, it makes it skinnier. If it's less than 1, it makes it wider. So even wider still, if we had y equals a third x squared, a third x squared would be wider still. So that's the first thing you have to remember. So this one makes it thinner, and this one here makes it wider. So I'll put that in brackets, fill that in if you want to. Alright, now the next one. These are called reflections, and they reflect in the x-axis. So if that's a generic equation of y equals x squared, remember that's what it looks like. When you've got y equals negative x squared, what it does is it flips it, or it's called a reflection in the x-axis. So that one gets flipped down, and this is what it looks like. So it doesn't look wider or skinnier because it's still the x squared one, but it's flipped upside down, and this one's called y equals negative x squared. Okay, so all we do is we flip it. Good job, that's reflections. So dilations make it thinner or wider, and then reflections flip it upside down. And now, remember how I said this one, the generic one, is a minimum. It forms a minimum value there. Now the reflected parabola, can you see here? It makes a maximum value. So this is low, 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 goes up to the top. That's a maximum, and then it comes down again. Alright. Now the last translation we're going to do is a movement. So we're going to translate it, move it, either up or down, or left or right. So let's look at the first one, y equals x squared plus 2. So the plus 2 means the whole thing's can be moved up 2 spots. And the turning point is very important here. So instead of being at 0, 0, we move it up 2. So that's a value of 0, 2. The y-intercept is at 2. And we put the exact same graph like that. So this one here is, where do I write it? So it's y equals x squared plus 2. So all you do is move that equation up 2. And the next one is y equals x squared minus 3. Yes, you're right, you move it down 3. So there's that turning point. You find minus 3, which is there, and it's the exact same graph. So try to make it exactly the same. It's not wider, it's not thinner, and that one there, it's just moved down 3. So y equals x squared minus 3. Okay, so that's your first translation, moving it up or moving it down. Now, of course, we've got to move it sideways as well. And if I have a look over here, when it's written like this in brackets, x minus 2 squared, this one's, it's a bit deceiving, this one's actually moves to the right. So, all we do here is move it 2 spots to the right. So there's our value 2. Even though it says minus 2 there, if you worked it out and did x-intercept like y equals 0 and then solve for x, you'll get x is equal to 2. So that gets moved 2 spots to the right, and then it's the generic parabola again. So we'll label that one y equals x minus 2 all squared. And this one here, x plus 1, all in brackets, all squared, moves 1 spot to the left. So that one moves, I like having these arrows there, just to show me, to remind me, okay, that one's going to move to the left, and then it's easy to work out. So that one there is negative 1, and there's my equation. There's my graph there, and I label it y equals x plus 1 squared. Okay, so I'm going to give you a quick summary, so you have to remember these. So, starting with the transformations, dilations. If we had y equals 5x squared, that's very skinny, it's skinnier. If we had y equals a quarter x squared, it's really, really wide. Okay, so skinnier and wider. Reflections. When you've got negative x squared, the negative means it flips upside down. That one's an easy one to remember. And then translations. People always seem to get confused with these. When it's x squared and it's just a plus 2 tacked onto the end, it's 2 up. And if it's a minus 3, it's 3 down. And then when you've got it in the brackets like that, a negative is actually to the right, so it moves it to the right, and if it's a positive, it moves it to the left. Alright, I'm going to let that sink in for a second, and I'll do my next section of this exercise. See you in a second. Hi kids, welcome back. Please copy down the next second lot of notes. Remember, nice and big diagrams, so we can fill it in. These are examples I'm going to talk about. Alright, okay, so now we're going to actually do some understanding about the parabolas. Okay, so it says here, write the key features down of this parabola. So let's have a look at it first. We know it's an upright parabola. So we can see the turning point is at the point 1 minus 4. this is called the y-intercept, it's at -3, or really it's 0, -3. And then there's two x-intercepts, one's at -1, 0, and one's at 3, 0. And it's an upright, we already said it's an upright parabola, which means that it's a minimum problem. So all we're going to do is write all that down. So, and hopefully you understand that from the first bit of the video. So the turning point is at 1, -4. That was easy. Is it a maximum or a minimum? It's a minimum, so we'll write that down. Now the axis of symmetry. Remember, this is a symmetrical parabola. So here's our axis of symmetry, this blue dotted line, and it's going through the point at x equals 1. So that equation is, funnily enough, x equals 1. So the axis of symmetry is x equals 1. That's the equation of that vertical line. The x-intercepts, so let's write them out properly. It's -1, 0 and 3, 0. And the y-intercept is at 0, -3. And that's it. Good job. You've just finished the first question. Let's do another one. Write down the key features of the second one. So we notice it's an upside down parabola. So the equation would be something like y equals -x², something like that. Probably a bit more complicated. So the turning point we can see is here. So the turning point is at -2, 0. Is it a maximum or a minimum? So it comes up to a maximum value. This time it's a maximum value. The axis of symmetry. Remember, the axis of symmetry is a line that goes straight through the turning point, and the x value of the turning point is -2, and that's the value that we need. So the axis of symmetry is x equals -2. The x-intercept, there's only one this time, because the turning point is on the x-axis. So the x-intercept is -2, 0. And the y-intercept, there's only one, always only one, and it's 0, -4. Good job, and that's that one done. Alright, now, I've made up this question here, and I've made lots of different, it's sort of similar to the last couple. So where's the turning point? So our turning point, we can see, is there. It's 1, 4. So I'm going to label it there. I'll write down the turning point is 1, 4. It's a maximum. So it's a maximum problem, or parabola. The axis of symmetry, it goes through there. So I'm just going to write down what the equation is, x equals 1. Because remember, it's a vertical line that goes through that turning point there. The x-intercepts. Now, I've made this intentionally a little bit tricky. So what did I say about a parabola? I'm going to actually put the axis of symmetry in. And I said that they're always symmetrical. So the first x-intercept is at -2, 0. Now, if that's -2 and that's 1, that's a distance of 3. So since this is symmetrical, the next point there must be another 3 further on. So that point must be 4. Just because we know it's a symmetrical graph, therefore we can work out what that one is. So that's 4, 0. And the y-intercept is 0, 3. That was easy. And we are done. Good job. But that little bit there, to find that point, it's just knowing showing that you understand that parabolas are symmetrical. Alright, now another one I've made up, and I've tried to incorporate all of those transformations into this parabola. So, just let's have a look at this, and I want you to sketch it with all the information you can. So let's have a look at it. It's negative, which means, from the translations, it's upside down, it's flipped or reflected in the x-axis. So it's an upside down parabola, which means it's a maximum. It's got a 3 out the front of it. So it's like having 3x². What does a 3 do out the front? It makes it skinnier. So it's a skinnier one. Now, a +2 inside the brackets. What does that do? That moves it 2 to the left. I like actually putting my arrows there, just so it makes it easier for me. And the +1 at the end means it goes 1 up. That's a turning point we're talking about. So our turning point's normally at 0, 0, right there. But in this case, we know it goes 2 to the left and 1 up. So there's my turning point, and I'm going to put these values in so I don't get confused. So it's 2 to the left and 1 up, so that my turning point is -2, 1. I'm going to label that on my graph. Alrighty, so it's a negative parabola, so it's upside down. We don't know exactly, unless we calculate the x and y intercepts, we don't know, but it's just asking for a sketch. So, and I know it's a skinnier one. So my normal one, I'd sort of, here's my normal one, I'd put it something like that, about that. But this one's skinnier, so I'm going to make it quite skinny, so it looks something like that. And because it's a sketch, it doesn't have to be completely accurate, but there's, in reference to my normal y equals negative x squared, that would be that one about there. So we know that this one's much skinnier. So as long as you show that in a test, show that it's skinnier, then you're going to get full marks for it. We've labelled our turning point because we know it goes 2 to the left and 1 up. So there's my turning point at negative 2, 1. It's skinnier and it's upside down because it's got a negative there. And there's my graph. Good job. Later on in further exercises, you'll be asked to find the x-intercepts and the y-intercept, and you do that from calculating like x-intercept, let y equal 0, and then factorise, and y-intercept, let x equal 0. So you've done all that before, but that's all for now. So there's your work, please, 7A, questions 1 to 8. Have a go at some of the ones after that if you're finding it easy, some of the problem-solving questions. And I'll see you next lesson. Good job, everyone.